Hello guys, and welcome back to Fun with Neural Networks. In today's video, we're going to be looking at the feed-forward activity in a neural network. And so feed-forward, yeah, that's why I drew that. So the architecture of choice for today is this two-layer neural network, where we have our input layer, our hidden layer, and our output layer. So notice I just called this a two-layer neural network, but I pointed out 3 different layers. So that's because the input layer is usually not counted when we are trying to describe a neural network architecture. Okay, so getting started, the first thing that happens is these connections, W1, they get dotted with X. And that's just a fancy way of saying we're trying to determine how much the X vector points in the direction of the W1 vector. Okay, so that dot product gets summed up to a bias term B1, which is also a vector. The sum of this gives rise to Z1, which lives right here. Okay, so Z1 passes through an activation function that gives us A1, right? And so the ones inside of these things, they just signify that, all they belong in the first layer. Okay, so anything for the first layer would have a 1, and anything that happens in the second layer would have a 2 right here. Okay, so at this point we're at A1, right? A1 is just an activation function applied to Z1, right? So the same thing happens again, but this time with A1 as our input and W2 as our weight matrix and B2 as our bias matrix. So this gives rise to Z2. That also passes through an activation. In this case, we're going to use sigmoid to give us A2. All right, A2 is our neural network's hypothesis. In other words, it's prediction, right? And so we need to find a way to, calculate just how off this hypothesis is from the real value. And so the loss function we use for this is this right here, and you're gonna see why this loss function is really nice. So that's the point of this entire series, to show you the beauty of some of these equations, why they're picked out. Yeah, we'll get to that in the backpropagation video. All right, so a quick look at the shape of these vectors and matrices. So the X is nx by m, and m is the number of examples that we have in our training set or whatever. And then nx in our case would be 4 because 1, 2, 3, 4, and so nx would be 4. Ny would be 1, ny 1 by m. W1 would be nh by nx, and in that case nh, this is nh, and I have 1, 2, 3, 4, 5, 6, 7, and so nh is 7. Yeah, so b1 would be 7 by 1, z1 would be 7 by m, a1 same size as z1 would be 7 by m, w2 would be ny by nh, and so that's 1 by 7. B2 would be 1 by 1, Z2 would be 1 by M. This is a mistake. It's going to be 1 by M. And A2 would be the same size as C2, 1 by M. All right, so that's about it for this video. Like I said, it's a relatively short one, or did I say that? Anywho, it's a relatively short one. And the next video, we're going to be looking at backpropagation, where we're going to be computing everything over here but in reverse.